Hello, everyone. Olaf introduced me already. I am a consultant at Liferay, and I have actually been for a while now. So my feeling is that our customers usually don't associate their systems with the term micro. Part of the reason certainly is that Liferay itself is a large web application, and the entirety of the platform and all the portlets can hardly be called lightweight. But of course, if you add like a JBoss, a WebSphere, or a WebLogic to the mix, it becomes even worse. So now you will probably ask yourself, like, why does he do that talk then? So one thing up front, this is not going to be a technical talk. This is more meant to be my view on how Liferay fits in with all the terminology that is floating around in the software architecture space right now, specifically microservices. All right, so like every good microservice presentation, I also want to have shipping metaphors. We'll see where I'm going with this later. So let's look at terminology first. So let's look at what is not micro. So let me introduce you to the inglorious monolith. So what they say about monoliths is that they usually come with an unmanageable complexity. So one of the symptoms you might see is that it's getting more costly to modify your application, it's getting more costly to extend your application. Your developers may be unhappy because they feel limited. They want to use bleeding edge technology. They want to use new frameworks, maybe different programming languages. All these things that come as an implication. And usually you also say that the components of a monolith are hard to reuse, mainly because they don't define their dependencies very well, but there's also nothing that enforces that. And then there's the thing that they say they have a one-dimensional scalability. What that means is, in order to scale a monolith, you usually just throw more instances at it. You can scale them horizontally, you say. But that doesn't tackle the problem of, I could have, several components in my monolithic application that may be CPU bound, another one may be memory bound. So they have different requirements. How do I address that in a monolithic application? But with this point, we actually already touch on the pros, which are the list below. Scaling an application horizontally is something operations usually understands. So everyone is aware of the concepts. It's a known concept to how to scale a monolithic application. They know how to deploy new versions of it. They know how to monitor that application. And of course, my developers know how to test that thing. So all these concepts are well understood for monolithic applications. So what's on the other side? On the other side, there is the so-called microservice. And I'm specifically referring to microservices in this case as a deployment option. Because it's a common conception that people look at it as an architecture, where I would argue that if microservices are inherent to your architecture, then there's something wrong, because actually that's not what you want. You want to have a modular architecture. You want to be able to split out components of your application when the need arises. So when you actually see you have problems with your monolithic application, that's the point where you want to split it. Having microservices as inherent part is probably not a good way to look at it. So, and of course, we want to have each of these components to be individually deployable. They usually rely on a lightweight communication channel, mostly HTTP, REST services. That's what is used nowadays for microservices mostly. And what you also want usually is to keep the central infrastructure required for your microservices at a minimum. And with this also comes, of course, the fact that you decentralize the data storage, or you can decentralize the data storage. So each of your components can actually talk to a different database, or maybe NoSQL, or whatever other data store you have. And one of the very big pros, of course, then is that I can iteratively develop. So I can get out new versions of single components one at a time whenever I want to deploy those single components. So this is a rather famous picture of how Martin Fowler kind of, visualized what a microservice is, or what we are talking about here. On the left side, you see those 4 big boxes, and each of them contains a number of colorful icons. Each of those icons is a service. So when you want to scale, you scale horizontally, as mentioned. So you just add more boxes of this big monolithic application with all these services. Whereas on the other side, for the microservice picture, let's imagine each of these services has its own little box. And you would be able to, like, say, oh, that little orange thing over there is a CPU-bound application, so I need to have that on like multiple boxes. While maybe the pink one is just very memory consuming and is not really used that much. So I just have that on one other node. So you're really able to individually scale each of the components. And I think that's, that's one of the main benefits people see in microservices. So theoretically, you would say, we could reduce complexity with this. But do we really? So let's look at a usual microservice architecture, how it may look like. And by the way, the following schema is something you can find in many places when people talk about microservices. It's also used by big analyst firms when they talk about microservices, something very similar to this. So the red boxes in this case are my business logic, so to say. So these are the actual components that contain my business logic. But in order to make them run, I of course need something to actually execute that code. So either I have a chatty, or I use Spring Boot, or whatever. I need something to execute them to make them run. And nowadays, it's also a given thing that each of those microservices then lives in a separate container with maybe different data stores. You would use like LexC or Docker or whatever for the containerization. Then nobody would run on bare metal anymore, so you of course need a virtualization technology, or you run in the cloud directly, so you would rely on like VMware or Hyper-V, but you can also go to like Amazon or Google Cloud or whatever. So, it's just natural nowadays. And then, of course, you realize that your microservices need a way to talk to each other. So you need to introduce a messaging channel, a communication channel for them, which is usually one of the established protocols like AMQP or MQTT. You have a RabbitMQ there handling the communication between them. And at that point, you realize, hey, how do I actually govern and manage all those services? I need to have a configuration and discovery layer, a routing layer for all these little services that I try to manage. I mean, I need to be aware of where they are running. And at that point, you may then ask yourself, how do I actually monitor those things? How do I aggregate logs over all these little applications? I need something to do that. And then you get into like, Kibana, Puppet, Logstash, whatever, you name it, just to aggregate logs and monitor those applications. So after you've set up all this, you may then be at a point where you can actually say, hey, let's handle some end-user requests. But it's quite some overhead, right? So I think, we didn't really reduce complexity. complexity is usually inherent to the business logic and your application, but also in this case, I think this is something that is widely accepted, even within the microservice community, that microservices come at the cost of increasing the operational overhead that you have. It's just a fact. So instead of one clustered application, you then end up with several micro applications that you need to cluster, you need to instrument them, you need to operate them. And instead of one single application server like you have maybe nowadays, you will end up with potentially a huge number of different runtime environments, maybe different operating systems, maybe several different application servers, whatever. It could be anything. Plus, you also face some design challenges with your microservices. You need to consider network latencies. Each of the services is talking to each other, so you need to consider that. You need to consider that you need to make them fault tolerant. So each of the components itself needs to be fault tolerant. If one dies, how do you handle that gracefully? You need to consider that you need to serialize objects before you can send them over the wire, which is usually not the case for in-process, monolithic application. You need to handle distributed transactions, for instance, which is a completely different beast of handling them in process in one application. And you need to monitor all this. Oh, it's kind of a lot. So again, going back to Martin Fowler, he said, all you're doing is shifting complexity from inside a component to the connections between the components. And that's a very difficult place to actually manage for your developers, especially for your developers. It's hard to control. And we don't want to end up like this. We don't want to end up so loosely coupled, maybe. So how do we get out of that dilemma? We want to have all these benefits. We want to, we want to have all the benefits of modular software development. We want to have iterative development cycles. We want to have independent deployability. We want to be attractive for developers. Yet, we are afraid of the operational overhead that this could cause. And what we certainly don't want is our components and microservices to end up on like wooden boats in the middle of the sea, which, by the way, seems to be what happened to those software developers over there, but maybe something else, we don't know. Anyway, so my point is we need something that can carry those modules and that can bring them somewhere. And maybe even gives us some guidance on how to make sure not to lose one of these components out in the ocean. So what about a platform? A platform would make sense, right? So this is where Liferay comes into play. So OSGi is a core technology of the new version of Liferay DXP. We have invested lots of time into modularizing our platform. We've invested lots of time into figuring out how to best work with the technology, and we tried to come up with best practices, of course. And it can save you a tremendous amount of time, to tell your fellow developers, do it like they did it, instead of like having them go figure it out themselves. And granted, our documentation is hasn't really caught up in all the places for what we're doing right now. But even for those places where it hasn't, you can still use the transparency of the platform itself. You can look at the source code, you can look at our issue trackers, you can look at our forums, whatever, you name it. So we are trying to be transparent in that regard. And if everything else fails, you can still ask support. So if you have Liferay DXP, that is. So for you, that really is an opportunity to modularize your code. You can iteratively modularize your code. So you don't need to do it in one big bang, like from today and tomorrow you need to modularize, but it gives you the opportunity to do that on a supported platform. And of course, you can learn from what we learned. We've, as I said, invested years, after all, into getting where we are now. So let's go back to that article that I mentioned of Martin Fowler. He said, you shouldn't start, and what we want to look at here is how does that relate to Liferay and what we did. He said, you shouldn't start with a microservice architecture. Well, we sure didn't. Instead, you should begin with a monolith. Yeah, we did. Then he said, keep it modular. We tried to back then, we tried. It still took us quite some time to actually modularize it. And then he says, and goes on with, and split it into microservices once the monolith becomes a problem. And that's what we kind of sort of did. We split it into microservices, only that it's not really the services Martin Fowler is referring to. But does it count still? I guess. Because what I'm referring to is OSGi Microservices. So it was, if you remember, the quote that I just showed you was from 2014, when Martin Fowler, defined what, according to him, are the characteristics of microservices. And it was 4 years before that, in 2010, when Peter Greens, which is another authority on microservices, even though he is, he means other microservices than Martin Fowler does. But still, he's a member of the OSGi Alliance since day one. And what he's saying in 2010 is, what I'm promoting is the idea of microservices, the concept of an OSGi service as a design primitive. That was, mind you, in 2010. So what we do have with OSGi microservices is the typical SOA pattern. So we have something that is producing a service, something that is consuming a service. The triangle in the middle for me is the service. So you can register your service. Another bundle can consume the service. It can listen for changes to the service. So that, it's a typical SOA pattern of, you would have called that broker in the middle probably. For OSGi, it's a service registry. And we get away from the very tight coupling that we had before into something more flexible. Now let's look at a random typical use case, right? So let's say your bundle A has a bug. So you realize there's a bug in it. What do I need to do in order to fix that gracefully, in order to avoid having to restart my application? So first, of course, I have to fix a bug. But then if I have another bundle version 1.1 of my bundle A, I will just deploy that. I will register it with the service registry. During that time, bundle B still holds on to version 1.A. So it will, keep working with what it has. But the moment you deinstall bundle 1.0, it will immediately fall back to the only available version, which is 1.1 in that case then. So you kind of have constructed, you could call it a self-healing system. So you deploy 2 versions, you remove that one that you had before, the buggy one, and your bundle B continues to work. It's all done during a runtime. So let's look again at the characteristics of microservices. And I think this list is pretty good, actually, for what it is. So on the left side, we have what Fowler said with regards to microservices and what their characteristics are. And we want to find out if that matches what we have in OSGi. So single applications as a suite of small services. Yeah, sure. That's something we have. You can build complex systems with a number of services. They're running in their own process. That's something we don't have usually in OSGi, because we are usually living in a single JVM. We don't have separate processes for each of the components. They are communicating with lightweight mechanisms. What's more lightweight than doing it in memory? Nothing, I guess. So yeah, sure. They are built around business capabilities. That's just a matter of how you develop. And by the way, we've been approaching this from a rather technical side right now of how to develop microservices or what the characteristics are. But of course, you need to adjust as a company to that development model. But that's no different for OSGi either. So you have to adjust your teams to actually be capable and be able to work in that setup. But sure, with OSGi, you have the same opportunities. You can focus around core business capabilities that you want to develop and set up your teams that way. We want to be independently deployable. That's, of course, a given thing. Microservice wouldn't make sense without that. Of course, with OSGi Microservices, as I just said, this is easily possible. You can just deploy any number of versions of different services. We want to have a minimum of centralized management. We do have that. It's just a service registry that we have, mainly that we use as the central point for getting and registering our services. He also said that microservices may be written in different programming languages. This is a yes and no answer for OSGi. I mean, you can use different in JVM or JVM compatible languages. You can program in like Scala, Groovy, and Java at the same time and deploy individual modules that are JVM compatible. So I guess it counts. So I put a check there. And you want to use different data storage technologies. Well, you're free to use whatever data storage is available to your bundle. That's easy. So yes, of course. So that list actually looks pretty good, right? So if we go back to the only cross that we had on that list, we still see that there is an inherent value to having out-of-process microservices. Mainly because it means full isolation of the components. So if one of your processes, one of your services runs amok, it won't affect the others. It won't crash the whole JVM. And the easy scalability that comes with it is also something that you should consider. For microservices, because it's easy to spawn up just a new process of a separate service, and you don't have that in OSGi usually. But OSGi remote services to the rescue, right? So there is a specification in OSGi that allows you to actually run bundles remotely via, for instance, web services. There are two OSGi specifications. One is the remote service specification, which takes care of the transport and how things are transmitted over the wire. And there's the remote service admin, specification, which takes care of topology, discovery of services. It's more or less an out-of-the-box thing. So you can theoretically run any bundle remotely. So we can also call this distributed OSGi if you want. So with OSGi remote services in general, do we really have the best of both worlds with regards to like the microservices Martin Fowler was referring to, versus the microservices that usually are in JVM? They are independently deployable. They are iteratively developable, if that is actually a word. Of course, so they are fault tolerant, kind of. As I told you, you can have multiple versions. They can fall back. They can, the system can almost heal itself. But you don't have the full isolation Fowler was talking about. You don't have network latencies, so this is something you don't need to care about. The call stack is, of course, greatly reduced to, compared to a real microservice architecture that has to go through all these HTTP hoops and in order to make and consume calls. You have definitely more freedom to choose your technology stack with OSGi remote services compared to non-OSGi Java in process. So you can have different data sources, you can have directly different programming languages, different frameworks. They won't affect each other. I mean, that is one of the main benefits of OSGi, that you have a real good isolation on a class path level between your bundles. So you can use different versions of different frameworks or the same framework. So you're really on the safe side there. And of course, it's less demanding for operations because conceptually, we're still running on a application server. Liferay, nowadays at least, is still running on application servers. You can still maintain your WebSphere web logic and still run an OSGi container on top of it within Liferay, in this case. And, all this comes, of course, with the fact that there are established monitoring and deployment strategies for application servers nowadays. So for operations, I guess it's, less of a hassle than monitoring hundreds, maybe, of separate applications. And I was actually expecting this to take way longer. Maybe I was talking too fast, but that's your time to actually ask me when I was talking too fast and you didn't get something. So, questions? No mean ones, please.
Okay, this is where I have a hard time coming up with the hardball question first. It's like, when? It's already there, but Lex is there coming to my rescue. Yay.
Oh no, that's going to be mean, right?
Hi. How does Microservice OSGi relate to WeDeploy?
Well, you're technically still running Liferay 7/DXP on WeDeploy. So I guess the same things apply. You can still deploy your bundles. You can still have the iterative deployment or development model and individual deployments and so on and so forth. So Milan, correct me if I'm wrong, but I don't see that there's a huge influence.
Yeah. Okay, sorry, that's me again. Okay, I think I know what Lex is talking about, and let's try to clarify. So I think the question is kind of like, okay, so if you say that Liferay is running microservices, then why are you building WeDeploy? Those are two different concerns there. Like one of the things that Daniel showed you is like OSGi and Liferay, they're very Java-centric, right? And also Liferay and Java and OSGi does not give you anything about like data persistence. So basically, if you ask where you store your data, from Liferay, we will always tell you wherever you wish. You use MySQL, you use Oracle, you use whatever you want. Right? We don't care. As long as you can handle it and we can connect to it, it's good. We're good for that. So now WeDeploy comes into the picture to fill that space, to give you more than the Liferay itself can give you. So it can give you like a general purpose authentication, which is not Java-centric, but you can use it from like JavaScript, you can use it from Ruby, you can use it from whatever you want, to give you a simple data storage, but powerful, that you can store data and search data and things like that. So it's up to you to choose and decide what makes more sense, whether you want to build your microservices as a OSGi component and run them in Liferay and benefit from the features that Liferay gives you, or you want to build them as a, I don't know, Node.js applications and throw them in WeDeploy and connect them to Liferay, for example. So it just gives you a lot more flexibility that a Java-centric platform itself can give you. Okay, so that is the two dimensions of WeDeploy versus Liferay.
So it's more or less external versus internal microservices. Yeah, but yeah. For my defense, I haven't seen your talk. I'm sorry.
Hello. Have you already given it a shot to use a different OSGi host to run some microservices and connect it to Liferay DXP and look how it runs? Have you given it a shot?
So are you referring to remote services?
Yeah, indeed.
So personally, no, I didn't. And you did? Come on. You want to answer my questions?
I'm not here.
Okay, before I give the chance for Milan maybe to jump in. So yeah, I'm not sure if there is active effort within Liferay apart from Milan to have something like that happen. Theoretically, like from all the conversations I had with like the OSGi people, it really looks like this is kind of an a solution that you put in place and it kind of sort of just works immediately. But I hope Milan has the same experience or has had the same experience. Do you want to? I mean, yeah, if it's beneficial.
I'm sorry for that. No. So yeah, you can actually do that. I mean, I actually have a talk that they've done in the past 2 years in a mini conference. You can Google it actually and see that in live, in action. It happens. So there's two questions though. One is generally do remote services. It's totally possible. And the tricky part is, do the Liferay's own services distributed? So if you want to get let's say, web content management services from Liferay and distribute only those, you can, but you need to be aware of the fact that they come with a lot of dependencies themselves. So it's not like scaling a single service, it's scaling a service that needs to bring some other dependencies out of it. So now the question that you want to answer yourself is, like, if I just scale one service but all its dependencies are actually removed, now how much of a traffic I introduce between nodes, right?
I was actually thinking at the other way around, thinking of having a separation between my front-end application, what lives inside of the Liferay, and having my business services living somewhere else in the backend to have some kind of application zoning where I have my more sensitive services. I don't want to be available directly from the internet somewhere, and however, having them available inside of the Liferay OSGi environment, so that I can use them there to make them somehow available to the internet. So I was thinking the other way around, actually.
It is totally possible, and actually I've done this, but again, it's like, as long as your service is independent, like totally independent, you don't even have to run it in Liferay. You can run it on like a simple Felix or Equinox container, just standalone service, and then simply consume it from Liferay using whichever distributed OSGi implementation works for you. So that's totally fine. If the complexity comes when you want to run a service that actually depends on other services of Liferay. Say, for example, you want to use, like, for example, asset framework, right? Well, then you need to figure out, like, whether I want to use it, my service is over there, my asset framework is over there, so they're going to be constantly talking to each other over a network, or do I want to deploy a micro version of Liferay on the other side? So this is where the parts get a little bit more complex, and you need to put more thinking into it. But if your service is, like, totally independent, there's absolutely no problem to do so.
Though from a security perspective, I'm not sure how high the gain would be, because essentially your services would still be available within your front-end Liferay instance, right? That's what you were saying, right? So if you use the native, remote OSGi capabilities, those services are still accessible within, the consumer side, if you're consuming them from your front-end Liferay instance. So I don't know how high, how big the security gain would be for this.
Well, there is a security spec in OSGi. That's a different story, though.
Yeah. I mean, that's different from just having them remote and expecting them, by just being remote, being more secure, right?
Yeah, being remote just basically adds more computing power, because that can be a totally different machine. But if it's accessible, then it's accessible.
Right.
I just have a flashback, and I'm now wondering if anybody ever interfaced Liferay with Corba. You have, okay. Okay, time for one more question, if somebody has one more question. Well, in this case, I would like to thank Daniel again